We got a brief overview of service objects last season, but it's time to take a deeper dive into services.
Hiya, Kaslin. It's good to see you. I was just getting ready to learn more about services. Maybe you could help me out?
Sure. I remember how we covered how services were used to abstract away pod lifecycle events last season.
Right, because pods are made to be started, stopped, terminated, and created, but oftentimes applications need to have a long-lived or permanent address to reach for interacting with services.
Yes. So if you had a server backend for storing images, it might not matter which pod serves the data back to your front end, but the front end would always need to know where to find your backend to request pictures.
And since each pod gets its own IP address, that would be a lot to manage, storing an IP address whenever a pod gets started or stopped. So services exist to store them for us, making app development much easier and more scalable. But I remember we created a special type of service last time called a load balancer. What was that about?
Well, see, there's more than just one type of service. Depending on what you're trying to do, one may be more suited to your needs. But before that, let's go into how to define services.
If I had a set of pods that each listen on TCP port 9376 and carry a label app equals my app, the YAML manifest file would look like this. This specification creates a new service object called myService, which targets TCP port 9376 on any pod with the app equals my app label. This is taking traffic from port 9376 and routing it to the pod's default port 80, which greatly simplifies app development. Wait a minute, what IP address does the service have? When I say it's getting traffic from port 9376, that must mean the service itself gets an IP address, right?
Right. Kubernetes assigns this service an IP address, which is sometimes called the ClusterIP. And this brings us to the first type of service, the default ClusterIP type. The ClusterIP service type is only reachable from other points within the cluster. We actually used these before last season to connect our front-end service to the auth and back-end services. All of those were running in Kubernetes, so they just needed a ClusterIP to talk to each other.
So then the next type must be the load balancer type that we also used in the last episode.
Well, actually, no. See, when you create a load balancer type service, you can see that it actually has an internal ClusterIP address. The load balancer service type also uses what's called a NodePort service underneath the hood.
The documentation says a NodePort service exposes a service on each node's IP at a static point. This type of service also has a cluster IP, and to access it, you reference the node IP NodePort address. Please help me make sense of why I would want to do this.
Great question. You see, the load balancer type actually uses node ports under the hood. At some level, pods are running on nodes, so the only way to access them is by actually talking to the machine they're on. The difference is that the load balancer types are pre-configured to use a cloud provider's load balancer for you. So if you're using GKE on Google Cloud, you'll be using Google Cloud's load balancer to distribute requests from your service to your pod instances. But what happens if you're running on-prem and don't have a cloud-provided load balancer? Or what about when you want to roll your own load balancer?
Oh, in that case, I'd need to access the NodePort myself, I guess.
Exactly. So we have ClusterIP services for routing internal traffic, node ports for allowing external access to a specific port on a specific machine, and load balancers for using cloud-provided load balancer to route traffic between a service's pods.
That's pretty robust. Are there any other types?
Well, there are more advanced types of services like external name services or headless services. And there's even a higher level object called ingress objects that are used to expose multiple services. But I think we can save those for another day.
Many thanks to Kaslin again for continuing to drop Kubernetes knowledge my way. I'm excited to go play with services more and see what I can create for myself. For more information about services, please check out the links in the description.